record and speaker view, and we're ready for you.
Okay, great. Well, welcome everybody. I am so glad you're here. It's been a great opportunity to get to know your children and the other families and the faculty members. I love math, and I hope that I can, and your children, a love of math too. There's a lot of kids that will say to me they're afraid of math or they have math anxiety. I have other kids that tell me it's their favorite subject, they love math. So we have a whole variety of people and children with their math experience. And I try to tell the kids not to be afraid, that I'll help them as best I can. I'll try to take them through it. And I'm really happy to say that. I mean, I've only been teaching 12 years, but I've had a lot of engineers that I've taught. It makes me so happy that I have one young man I'm still in touch with. He went to Villanova. He's got a great job at Lockheed Martin. He's getting his master's now that Lockheed is paying for. And I have another young lady who just told me, she called me the other day, or texted me, that she just got into Tufts Dental. And I was her math teacher, and I have a kid that went to Cornell, some great schools and some really terrific kids. So I'm just going to kind of pop into a short little lesson about substitution. Not what you're doing in a restaurant, but what we're going to do a little bit substitution here is a math lesson. Kim, can I get to my blackboard from here? Can you hear me, Kim?
Sorry, I was muted. So if I put you as host, which I can do right now, then you can share your screen.
Perfect. Thank you.
Yep, you're welcome. Thanks. All right, so you're the host now.
Perfect. Thanks, Kim.
You're welcome.
All right, so there we go. So one of the first things we're going to do here is just kind of take a quick look at a coordinate plane, okay? And we can do all kinds of things here on this coordinate plane. We can do a positive slope, a positive graph, positive slope. We can also do a negative slope, okay? And draw a line just to go showing a decline. So one of the lessons I'd like to do on substitution is, I don't know how many of you remember this lovely little equation called y equals nx plus b. Well, m is the slope, okay? Now, I'll tell you a little quick story. When I did this, I practiced on my sister the other day. She's about 15 years older than I am. She was a math whiz, and she didn't remember any of this. She was almost 75, though, and she had a perfect math SAT, but she goes, I don't remember any of it, Mary. I said, that's okay. So here is this, what we call the slope-intercept formula or form of a line. So it's a linear relationship, okay? M being the slope, B being where it crosses the axis here, the y-intercept. So we're going to take two equations. This is what I've been working on with the algebra kids. We're going to take these two equations, and I tell them we are solving for a system of equations. It's only two equations, but it is a system. And we talk a lot about in class systematic stuff in engineering and finance and medicine. I give them a few examples about Sikorsky, about Pitney Bowes, about things with graphs in medicine, and we talk about this while we're solving the system of equations. So let's take this one we're going to take a negative x plus y, and that's going to equal 1. So that's one equation, and we could write it to look like this if we wanted to. I'm just going to keep it in this form. And then we have another equation that looks like this. 2x plus y equals negative 2. So if you were an engineer, they could come to you and say, for those two equations, what's the solution? And if you had taken algebra, algebra 2, etc., you'd say, oh, I can solve this. I can graph these. And where the 2 points meet, where they intersect, that's the answer. That's the ordered pair that answers that. That's one way to do it. We're not going to do that tonight. I'm going to show you how to do it using substitution. So let's first look at this equation here. And by the way, the x's and the y's are variables, and they stand for a number. They represent some unknown. Okay, so let's first look at this equation. I'm going to take this equation, and I'm going to take the y. I'm right here, guys. I'm going to take the y, and I'm going to say that y equals x plus 1. All I did was move this over here. I went plus x here, and I'm going plus x here. So this and this cancel out. So now you just have that y equals x plus 1. Does everybody get that? I guess you can't say anything, but okay. So all I did was manipulate the equation so that I had y equals x plus 1. That's all I did. So now that you have that, well, guess what? There's a y over here. See it? So I know now that y equals this. So I'm going to take this stuff and I'm going to substitute it in there. The reason I want to do that is in order for me to solve for x and y and come up with the ordered pair that's the solution for the system of equations, I can't solve it if I have two variables and I have two unknowns. So I have to get this equation down to one variable. That's why I'm doing this. Is everybody with me? So now watch what I'm going to do. I'm going to write this equation, the second equation now, as 2x, okay, plus, and instead of writing y, I'm going to take this stuff. X plus 1 equals, and this is what it equals, negative 2. Okay? So far, so good? Now we're going to do this thing that we learned, the kids and I learned, I don't know, a couple months ago, where we combine like terms. So what's really nice about math, and what's great about the books we use, the Saxon books are wonderful, is they build. So what we learned a couple months ago, and the kids will say to me, oh yeah, I remember Mrs. Sinise when we did that. Mm-hmm. So great when they say that. So now what we're going to do is we're going to combine like terms, and see this 2x and this x? We can combine those. And they become, I'm going to erase it, well, I don't want to erase yet. They become 3x, okay, plus 1 equals, whoops, sorry about that, negative, I'm getting a little messy here, hold on. Okay, equals negative 2. Okay, so now we have to do this thing where we isolate the variable. We isolate the x or the y. Okay, so I have to get the I tell the kids, I got to get the letters on one side of the equal sign, and I have to get the numbers on the other side of the equal sign. That's the only way you can isolate the variable and then solve for it, okay? So we'll do this in steps, and it really is the reverse order of operations, but don't worry about that. But that's truly what it is. So watch what I'm going to do. You ready? See this one here, this positive one? I need to get rid of that. And I need to balance the equation. And what I do here, okay, I have to do here. All about balancing the equation. So now this goes away because a +1 and a -1 are 0. But now, I have 3x equals, you with me? This is going away. I'm bringing my equal. And now we're going to add these. It's a -3. Okay?
Mm-hmm.
I have to solve for this. I have to divide each side by 3. 3 divided by 3 is 1. But if the coefficient is 1, I just write x. So x equals -3 divided by 3, which is -1. Okay?
Yes.
Now, all I have to do is watch. Put this back in here, and now I have my y. Y equals -1 plus 1, which equals 0. Okay? So, what does that tell us? Let me tell you what that tells us. So we know that x is -1 and y is 0. So we write an ordered pair. Whoops. We write an ordered pair like this. Right?
Mm-hmm.
X comma y. So the solution to the set of those two original equations is -1 comma 0. So what that means, I think I'm getting out of a zone here. I can't write. What that means is that, just going to clean up my board a little bit, guys. Sorry.
Mm-hmm.
It means that if I make my coordinate plane, right, and I have my x here, my x-axis here, my y-axis here, right? And now I'm going to plot this. So I'm going to go over -1 and right on the axis there, right on 0. That's my point. Now, what does that mean? What does -1, 0 mean? Yes, I just said that it's a solution to the system of equations. But what does it mean in real life? So what I talk to the kids about, and I just draw from my experience, is let's say you had a line like this and you had a line like this. I should do this with the other. Hold on a sec, guys. Let me clean this up a little bit. So if I had my graph, right? And then I have the line that goes like this, right? And then I have another line that goes like that. That point where they intersect is that point. What this could mean is that this line, which represented one of the equations, say you worked at Sikorsky, that might be the strength of materials for the rotors in sand when it hits sand. And then this line might be the strength of materials for rotors when it hits wind, or maybe a flock of birds or whatever. And there may be, obviously there would be much more complicated equations, but it may be that some engineer has to, or a team of engineers has to take that and say, oh, well, what's the type of material we need where we have the optimal operation, where they're not going to fall apart if they hit sand or wind or birds at these speeds, etc. And that's what I try to explain to the kids, that's what a system is. I explain to them that, when you work in a real company, the electrical engineers, the software engineers, and the mechanical engineers, and the manufacturing people, and the sales guys, and the marketing people, they all have to get along, and they all have to like get the product out so that a customer is happy. It's not just you sitting in your little cubicle or in front of your laptop and you're happy and doing your thing. You've got to get along with the team and make sure that these systems work together. So anyway, that's a system of equations. I can do another one for you, but we could talk about different things too, whatever you'd like to do.
All right, hang on a second, Mary. Let me